The science behind black holes, explained in simple words. Among the most peculiar and intriguing objects in space are black holes. Because of their enormous density and powerful gravitational pull, not even light can elude them. More than 100 million black holes may exist in the Milky Way, yet it is incredibly challenging to find these ravenous monsters. Sagittarius A star is a supermassive black hole located at the center of the Milky Way. According to a NASA statement, the enormous structure is roughly 26,000 light-years from Earth and has a mass of 4 million times that of the Sun. The Event Horizon Telescope EHT team took the first picture of a black hole in 2019. Scientists worldwide were pleased by the stunning image of the black hole at the center of the M87 galaxy, which is located 55 million light-years from Earth. What causes black holes to form? It is anticipated that black holes would originate through two different pathways. The first pathway states that they form when huge stars die because they are stellar corpses. When stars with birth masses more than around 8 to 10 times that of our Sun run out of hydrogen, they burst and die, leaving behind a very compact, dense entity known as a black hole. The black hole that remains after this process is known as a stellar mass black hole, and it has a mass that is several times that of the Sun. White dwarfs or neutron stars are left behind by stars with lower birth masses than black holes. The direct collapse of gas is another method by which black holes form, and it is anticipated that this process would produce more gigantic black holes with masses that range from 1,000 times that of the Sun to even 100,000 times greater. This route, which is thought to function in the early cosmos and generate more massive black hole seeds, avoids the development of the conventional star. Black holes were discovered by whom? It was expected that black holes would be the precise mathematical answer to Einstein's equations. The form of space around matter is described by Einstein's equations. The precise distribution of matter is linked to the geometry or shape of a shape by the theory of general relativity. Carl Schwarzschild discovered the black hole solution in 1915. It was discovered that these areas, or black holes, caused extreme spatial distortion and created a hole in space-time. Whether these matched actual objects in the universe was unknown at the time. It became evident that black holes were real and should exist when other byproducts of stellar death, such as neutron stars that were perceived as pulsars, were discovered over time. Cygnus X1 was the first black hole to be discovered. Do black holes die? Theoretically, black holes will eventually slowly evaporate over incredibly vast timescales. However, they do not die. Black holes are created when nearby stuff is drawn in by their powerful gravity. Hawking also predicted that black holes might shrink very slowly and radiate out energy. According to quantum theory, virtual particles are constantly appearing and disappearing. A particle and its counterpart antiparticle emerge as a result. They can, however, also reassemble and vanish once more. Odd things can happen when this procedure takes place close to a black hole's event horizon. One particle can defy gravity and fall into the black hole, while the other particle can fly off into space, rather than the particle-antimatter pair existing for a brief time and then annihilating one another. According to the idea, this trickle of escaping particles will cause the black hole to gradually evaporate over very long periods, by which we mean timescales that are far, far longer than the age of our universe. Do wormholes exist in black holes? Wormholes are not black holes. Wormholes are similar to tunnels that link two different locations in space and time. It is thought that wormholes, which breach space-time, may exist inside black holes and provide access to other points in space-time, possibly even to other universes. The first black hole found. In 1916, Albert Einstein's general theory of relativity made the first prediction about the existence of black holes. The American astronomer John Wheeler first used the term black hole in 1967, many years later. After black holes were only recognized as hypothetical things for decades. Cygnus X1, which is situated in the Milky Way's Cygnus, the Swan constellation, was the first black hole ever found. According to NASA, a sounding rocket discovered celestial sources of X-rays in 1964, giving astronomers the first indications of a black hole. Astronomers discovered in 1971 that the source of the X-rays was a bright blue star circling an odd dark object. The observed X-rays were thought to be the consequence of stellar material being gobbled up by the dark object, an all-consuming black hole, after being peeled away from the blazing star. What is the number of black holes? About 1 star in every 1,000 is large enough to turn into a black hole, according to the Space Telescope Science Institute (STSCI). There must be about 100 million black holes in our galaxy because the Milky Way has more than 100 billion stars. NASA thinks that the number of stellar black holes in the Milky Way may range from 10 million to a billion, despite the fact that black hole detection is a challenging task. Gaia BH1 is the nearest black hole to Earth, located just 1,560 light-years away. Double trouble for binary black holes. In 2015, gravitational waves from merging star black holes were observed by scientists using the Laser Interferometer Gravitational Wave Observatory, LIGO. In a statement, LIGO, Scientific Collaboration, LSC spokesperson David Shoemaker said, "We have further confirmation of the existence of stellar mass black holes that are larger than 20 solar masses. These are objects we didn't know existed before LIGO detected them." Additionally, LIGO's observations shed light on a black hole's spin orientation. 2 black holes can spin in the same direction or the opposite direction as they spiral around each other. Binary black hole formation is explained by 2 different ideas. According to the first theory, 2 stars that were created together and died explosively around the same time may have formed 2 black holes in a binary at roughly the same time. The 2 black holes that were left behind would have shared the same spin orientation as the companion stars. According to the second hypothesis, black holes in a star cluster team up and sink to the cluster's center. According to LIGO Scientific Collaboration, these companions would have unpredictable spin orientations about one another. This creation scenario is further supported by LIGO's discoveries of companion black holes with varying spin orientations. "We're beginning to collect actual data on binary black hole systems," said Keita Kawabe, a Caltech LIGO scientist stationed at the LIGO Hanford Observatory. "That's interesting because some models of black hole binary formation are somewhat favored over the others even now, and in the future, we can further narrow this down." Some facts about black holes. Gravity would stretch you out like spaghetti if you went into a black hole, according to long-held belief, but you would die before you reached the singularity. However, according to a 2012 study in the journal Nature, quantum effects would make the event horizon behave like a wall of fire, quickly killing you. Black holes are not bad. Pulling something into a vacuum is what causes suction, and the enormous black hole is most clearly not one. Rather, things fall into them in the same way that they fall toward the Earth or anything else that has gravity. Cygnus X1 is the first object thought to be a black hole. Stephen Hawking and colleague physicist Kip Thorne placed a friendly bet on Cygnus X1 in 1974, with Hawking speculating that the source was not a black hole. Hawking admitted defeat in 1990. It's possible that tiny black holes originated right after the Big Bang. Some areas may have been compressed into small, dense black holes that are smaller than the Sun due to space's rapid expansion. A star may be ripped apart if it approaches a black hole too closely. With masses about 3 times that of the Sun, astronomers estimate that there are between 10 million and 1 billion stellar black holes in the Milky Way. Science fiction novels and films continue to make excellent use of black holes. Take the film Interstellar, which made extensive use of Thorne's science. Scientists now have a better idea of how far off stars may seem when viewed close to a rapidly rotating black hole because of Thorne's work with the film's special effects crew. Enjoyed this? Don't forget to like, subscribe, and comment. Let's keep the conversation going.